Good afternoon, everybody.
My name's Eric Shea. I've been a student of IB Remsen for a long time. He's got over 50 years experience as a potter, instructor, teacher, art administrator. Currently he heads the ceramics department at Washtenaw Community College in Ann Arbor, Michigan. By the way, he's originally from Pittsburgh, so it's really a special honor for me just to be here at an occasion like this. He knows this town. He grew up here. He's currently heading the ceramics department at Washtenaw. His background is he has a BA in anthropology and art, 1969 from Antioch College. He worked on Michigan Masters of Fine Arts program, 1969 to 1971. And he did his work under Bob Stull and John Stevenson. Previously to that, he obtained a certificate of excellence at Capella Garden in Vickelby, Sweden. And this was a school that emphasized traditional Swedish crafts. It followed the slip-decorated earthenware tradition of pottery that was part of 18th century Swedish culture. And in form and decoration, it strongly resembles Pennsylvania Dutch and early Moravian pottery. And after that, he stayed in Sweden and actually worked as a employed potter doing throwing. A really young guy. It's very impressive that he was able to do this at that age in Sweden. Since 1971, he's also had his own studio in Ann Arbor, which is very impressive. His work is amazing. His teaching, aside from WCC, he taught for years at Adrian College, going from about 1999 to 2005. He's also taught at the Ann Arbor Art Association, Ann Arbor Potters Guild, Kalamazoo Institute of Arts, Lansing Potters Guild, Pewabic Pottery, Michigan Extension Service for Continuing Education in the Arts, Michigan Council for the Arts, and he's taught over the years several times at both Ann Arbor Art Association and the Ann Arbor Potters Guild. He's exhibited prolifically, including at the Smithsonian Institution. His work has been juried by such notables as John Glick, and he's exhibited Eastern Michigan University, Apropos Gallery in Cambridge, Michigan Potters Association, Pontiac Art Center in Pontiac, Michigan, Springfield Art Center, Springfield, Illinois, Kalamazoo Art Museum, Signature Gallery in Atlanta, Lancaster Museum of Art in Lancaster, PA, Paddington Art Gallery in Perth, Australia, and Ella Sharp Museum in Jackson. As an art administrator, IB has juried the Ann Arbor Street Fair, Art at the Point, board member of the Michigan Potters Association, juried the Spectrum Gallery annual show in Toledo, Art World's annual exhibition. He has been the president of the board of directors of the Ann Arbor Art Association, co-founded University of Michigan Artists and Craftsmen's Guild 1970. He was a finalist 1991 at the Annie Awards in 3D Art, Merit Award, Michigan Potters Association, twice at the Michigan Potters Association, 1983 and 1984. He did a dinner service commission and received an award from Governor and Mrs. Milligan, and that was at Michigan Dinnerware Competition in 1982. Best of Show Toledo Festival of the Arts 1981. Riverfront Arts Festival, Evansville, Indiana. Merit Award, Michigan Potters Annual Show 1981. Publications, numerous, just to name a few: Ceramics Technical, Studio Potter, Extruded Ceramics. He's been written up in the Detroit Free Press, Washington Post, Ceramics Monthly, Michigan Daily. Selected commissions include United Way of Washtenaw County, American Lung Association, the White House in Washington, D.C., 1993. And among other, his selected collections, among others, Greater Arts Association of Greater Toledo. And he's actually done work for Mrs. Joan Mondale, who's known as Joan of Art. She's a distinguished potter. That's the wife of Fritz Mondale, who was almost president. So his experience is vast. If I gave you all the details, he wouldn't be able to speak. But he's a great guy and a great instructor. I'm someone who've worked with both Cone 6 and Cone 10, and I think he's absolutely right about Cone 6. He's going to tell you all the advantages, and I'm sure this is going to be an enriching experience. I'm proud to introduce my friend and instructor, IB Remsen.
Well, Eric, thank you very much. Isn't this a wonderful conference? I've never been to a conference. I've been to a lot of them, and this is really one of the better ones. And I'm thrilled and privileged to be here. I'm here to convince you that you can get everything that you got from Cone 10 at Cone 6. And not only am I going to convince you of that, I'm going to give you 5 or 6 glazes that you've always loved at Cone 10 that work at Cone 6. I'm going to give you Tomoku, I'm going to give you Copper Purple, Copper Red, I'm going to give you Shino, and I'm going to give you Chun. And all of these work at 6, and you will see them. So how did I do this? Well, I'm not a chemistry genius, and that RO1, RO2 stuff, I don't understand it at all. What I understand is what you see is that it's on the screen here. That's Robin Hopper. He came by my studio once. I had him sign a copy of this and I put it in my studio. No matter how one creates a glaze, the key to understanding phenomena or glaze development lies with the understanding of the individual materials involved, their expected behavior under variations of temperature and atmosphere, and their interaction with each other. As one develops knowledge of these materials, one is also likely to develop intuition as their potential interaction. Intuition leads to a type of understanding that allows and encourages individual growth. So really what he's talking about here is treating glaze development the way a cook might treat cooking and glaze recipes. You just figure out what works. I had an older guy who been at the university as a research scientist. He came and take ceramics. And he only took 1 semester with me, but towards the end of the semester, he said, I've been looking in that glaze book and I've been looking at your glazes. And he says, they all have silica and alumina. The only thing that's different in them is the flux and the colorants. I said, bingo, that's it. If you can understand that, you can understand glazes. So what I've done, we're going to move on here, is no, that's just what Eric told you, so we don't have to worry about that. So everything I give you here will be accessible afterwards, so you don't have to worry about writing it down. So we fire in a mid-sized guile kiln, about the 35 or 40 cubic foot kiln. For all the reduction work, we have the larger car kiln, but we don't use that for reduction. We could. I'm kind of old-fashioned, so I like the mid-sized guile because it's the one that's brick. And this is what it looks like after over 100 glaze firings at Cone 6. Really, not much in the way of wear and tear, even around the burner ports. So we're very happy with that. Our door is still tight. Our arch is still solid. We don't have any cracks around in the back wall, and we don't have any deterioration of brick around the burner port. Right, that's what I've told you. And you can look at the roof here. We've got that one little line down there, but I think that's because the metal frame, the metal box is actually stretched out a little bit. But still, after 100 glaze firings, this kiln is looking very good, and probably good for at least 500 more before we have to replace it. One of the advantages of firing at Cone 6 is that you can look at this firing chart here. Because it's a guile kiln, I'm able to set it to a temperature and hold the temperature. And then I come in the morning, and then 6 hours later I'm done. And I've basically done all the heavy lifting of glaze firing and glaze development, in my opinion, takes place between 1400 and 2200. So you can look at the chart here, and what the first part of the chart shows that it's been sitting there at 1400 for a while, and I come in at 9 or whatever, and I turn on all the main burners. I cut the damper back, and we try and hold it almost at temperature for an hour or a half an hour. And during that time, the burners are backing up out of the bottom of the kiln. There's flame coming out of the door, but we only do it for about a half an hour. And you can see, here's another chart. The same thing. Every firing is pretty much the same, but I keep a log mainly because I want to be aware of things that might change, that might indicate that there's something happening with the kill. My experience is that kills slowly do change over time, and the firing pattern changes along with the changes in the kill. And I keep a log of every firing so that I can, if things are starting to happen, I can look back and kind of pinpoint when did this start to happen. The first part of the firing, this is how the burners look on the bottom. They're backing out. We're getting lots of carbon in the kiln, and it's getting all over the Shinos, and it gets into some of the other glazes as well. But then after that, we keep the gas on full. We open up the damper to the point where it will still maintain reduction, just barely, at the bottom of the kiln. And that's pretty much what we do. That's how we fire it off. And during the whole firing, we always are looking for this at the bottom of the door. We're looking for the tiniest little flame coming out of the bottom of the door. So that tells me that reduction is the flame is backed up all the way to the floor. And there's just a little bit. If you see big honking shots of flame out the bottom of the door, there's no point in doing that. There's a good chance you're going to muddy up your glazes. I think in the I said yes, and we do right. So we after the first hour or half hour of basically soaking and basically putting carbon all inside the kiln, we pull the damper to gain heat, and we do a clearing. We do a 5-minute oxidation fire at about 1800 and at the end of the firing, and that's all. Okay, so we get down here. So that's what the door looks like. I was talking with some students, and they were talking about how there's a big uproar in their class about which program to use in firing their kill, which program works the best. And I said, well, if you come to my class, you won't hear anything about a program. So this is how much flame is coming out of the bottom of the door during the regular heat rise and mild reduction. This is how much flame is coming out of the stack. And then at the end of the firing, this is what the kiln looks like. This is the most recent firing. I just took a couple of pictures just for illustration. And we have some nice Shino, some copper greens, on the lower left there. There's some nice Shinos in there. You can see that pot in the back there. I'll give you a close-up on that. And there's some nice Tomokus. And there's some nice specialty glazes there. Now, these two pieces here, it's not a particularly good shot, but it's a good illustration of what happens when you cross over and do cone 6 reduction and oxidation. What will happen in your studio is that students will really not pay attention and understand that some glazes are for reduction, some glazes are for oxidation, and oxidation glazes will get into the reduction kiln, and vice versa. And what you find out is that these glazes that were designed for a particular type of firing have wonderful potential in the other type of firing. This piece here is made by a gentleman right in the front row here, and that sparkly metally thing like the glaze on the outside of that pot, that's really a glaze that we call iron red. It's 25% iron oxide, and we use it in oxidation to simulate an Ojada red in oxidation. But in reduction, on top of another glaze, it breaks down and creates all these iron crystals. It never does this in oxidation. And then we take this other piece. This is anybody in this room at Cone 10 ever use a glaze called Schweiger Blue? Brad Schweiger blue? No. Anyway, that's my version of the Cone 6 Schweiger blue. You'll see. Look at that in a second. And here's the here's the cone pack. 7 is up, 6 is over. The piece right next to it, that is Jen Graff's Juicy Fruit in reduction. Jen Graff worked with us for years ago. Now, everybody knows her glaze is Jen's Juicy Fruit, but actually her name is Jen Graff, and she made the glaze. I hoped she would be here today so I could acknowledge her, because Jen's Juicy Fruit seems to be everywhere. Okay, here's a piece. Okay, that's the Shino, Cone 6 reduction. We're able to control the yellow and the gray by applying wax to the surface. Sometimes. Sometimes. Most times. On a good day. Here's a nice Tomoku piece that came out. Okay, so my Tomoku. Okay, there it is. Remsen Cone 6 Tomoku. All right, all right. I started off with the glaze you see on the left there, which would Rex Fote, a friend of mine from Toledo, who went to school with him. I was telling him about I had trouble with this glaze and that glaze, and he says, IB, why don't you just try 5221? I said, what's that? 5221 is a standard high fire glaze, apparently. 5 spar, 2 flux, 2 silica, 1 kaolin. It becomes, many of the high fire glazes started off this way. So with 8% iron oxide. So what I did was I said, the way I approach lowering temperature in glaze, unless it's a funny glaze that needs special attention, I treat frits as low temperature feldspars. That's the way I do it. That's the secret right there. You just pull the feldspar, you substitute frit. Or and some of the other glazes, sometimes you can go, if you have like Custer spar in there, you can substitute Nefsi. Nefsi is a slightly lower temperature. Or you can do a combination of both. You can substitute a lower temperature spar for a higher temperature spar, or a really low temperature spar, which otherwise known as a frit. So this is the first conversion that I did, and all I did was essentially create a base of 110 grams rather than 110% rather than 100%, and when I put in 10%, 3110, and then I ended up with those numbers on the right side of the decimal point, which I don't like. So I never did that again, and I'll show you what that looks like later on. After this, as you can see here, I did the same thing. I substituted Nefsi for Custer and added 10% 3110. And everything else stays the same. All the secondary fluxes, the amount of clay, everything stays the same, and you just lower the temperature. Okay, and we're going to go. What am I doing? Push the green button. Not happening. Okay, there we go. All right, so this is the Tomoku, and this is the Shino, and this is the wax on top of the Shino to create the images. This is a student piece. This is the Tomoku. It's a little the color registration is a little off. It's actually browner. It looks a little red to me. No button. Okay. Here's another. This is a student piece. This is Tomoku. For some reason we're not. I know, but my button's not. Okay, there we go. This is a copper red glaze, purple haze on top of Tomoku. Okay, what am I doing wrong here? I'm not getting buttons to go forward. Okay. This is a really interesting piece. This is Tomoku with Jen's Juicy Fruit. And the Jen's Juicy Fruit is making all that blue stuff in the middle, and then with a copper red glaze in the middle. and we'll just look at a couple. We're going to see Jen's Juicy Fruit in a second here. Here's another one showing a nice little bleed of the Tomoko on the edge. Now this is assisted by an iron rutile wash, which we borrowed from John Glick a long time ago and then modified with a little bit of flux. Another one, this is the Tomoko with some of the copper and Juicy Fruit. Okay, and another one. Okay, so this is the Tomoko with the Chun, and then the red glaze and the Juicy Fruit. And we'll just look at this here, running through this. Jen grabs Juicy Fruit. Okay, we'll look at blue Celadon. This is, I used a Celadon a lot when I was doing my own glaze, my own production work. And this is one of the pieces that I did. I would put Celadon over iron saturate slip to get this effect, and I really did like it, and I was sad to leave it. But then, when I developed my blue Celadon, I was able to do the same thing at low temperature. The first one you saw was cone 10. This one is cone 6. So this is Celadon over an iron saturate slip with a little bit of marbling and feather trailing, and the last thing in the Celadon is the Celadon with iron rutile wash, Albany cobalt wash, and a little bit of Tomoko cone 6 reduction. Okay, copper blue, Schweiger blue. This is what Schweiger blue looks like in at cone 10. And here it is again on the rim of a plate at cone 10, and I was able to modify it for cone 6, and that's what it looks like at cone 6. Probably doesn't need as much copper as it's got in there. We could probably get a little more green if we just lowered the copper a little bit. And here's another piece, cone 6. The Schweiger blue formula. Hey, this is all on a file somewhere. You should be able to access all of this stuff. So, what did I do here? I increased the fluxes and reduced the NEFSI by 10%. I kept the kaolin and the flint pretty much the same. This is really all it takes. When you think about it, Wedgwood did something over like 5,000 or 6,000 tests over his lifetime, and he didn't really know anything about this. Okay, Remsen wet Shino, derived from the red Shino, blocky on the name. This is one of my students. This is one of her pieces. Again, the difference between the carbon trap pieces and the Shino pieces, and the red is basically where wax was applied. This is the Shino with the copper red glaze. There's the Shino all by itself. There's the Shino with purple haze and a little bit of lacquer resist on the surface there. Here is the Shino with the iron red. There's the Shino with the purple haze. There's a beautiful piece there. Beautiful piece. Shino covered completely, protected with wax. Shino with something else, I don't know. And this next one, okay, so this is what happens. This is what happens if you try and do heavy reduction at the end of the firing. You get wonderful results for about 1/3 of your pots. The other third of your pots are relatively untouched, and the other third of your pots are completely bleached out. Because when you do heavy reduction at the end, you just suck all this cold air into the bottom half of your kiln in around your door, and all that copper red disappears. How do I know this? Yeah, well, you know how I know this. Here's a piece of Eric's, the guy that introduced me. He loves to cut pots apart and stick them back together. This is a Shino with Pete's Weathered Blue. Pete's Weathered Blue, a standard copper 6 glaze. And there's the Shino with the little bit of Vince's Lavender. And we got a little bit of Shino there. And we're going to keep going there. Okay. That's the last Shino piece. No, not quite. All right. Yeah, beautiful pieces. All right. Malcolm Davis's Carbon Trap. That's what it was that I turned into a wet Shino. All right, so here's the reds. These are our cone 6 copper reds. This is the Remsen red. And now we go to, oh, wait a second. Sorry. Okay, ready? Okay, all right. All right, Purple Haze, the glaze that keeps on giving. And I'll explain that in a minute here. This is one coat of one glaze. Look at the variation. This is a glaze that originally came out as a Tom Coleman glaze, and he called it, I think, lipstick purple. And I did some modifications, and it basically comes out this way every time if you do the firing schedules that I showed you. Here's a student piece. Here's a slab piece. Another student piece. And here's the Purple Haze with the iron rutile wash over it. And here's a piece done by our very own Cheryl Green, sitting in the second row here. So we have licorice and seafoam, which are kind of two standard oxidation glazes that we just started to fool around with in reduction. Got some great results. All right, get your cameras up. You ready? All right, okay, there we go. Tom Coleman's Purple Maroon into IB's Purple Haze. Okay. Yes, okay. All right. This glaze, has a lot of variation, but all the variations are great. And that is, there it is. Okay. And it's good in combination with the Shino. And here's a piece that shows you, I think the lid and the pot were fired on two different parts of the shelf. You can look at the variation there. Cone 6 reduction. Way to go. Student work here, combining the plum red with the Shino. Again, plum red with Shino and a gray blue. Gray blue is a kind of standard oxidation glaze we've been using for years. Throw it in reduction and all of a sudden it comes to life. All right, the secret to the plum red glaze. It's the Purple Haze base with less copper. So the Purple Haze is this base with 1.5% copper. Plum red is the Purple Haze base with 0.25% copper. Okay, Chun Blue. This is an early piece of Chun Blue, and I have a leach overglaze that I tried on it. But we got some, it's a student piece. This is Chun Blue with a little bit of copper red on it. And what we discovered was that if you put Chun Blue on an iron-bearing glaze, like a terracotta type glaze, all of a sudden it turns a lot more blue. And it also helps the reds. So this is marbled terracotta and stoneware. And here's some terracotta piece with Purple Haze on the inside and Chun and Purple Haze on the outside. But the Chun Blue is so sensitive that if you take copper sulfate in the thinnest possible solution, you can't even see the color in it, and brush it onto the glaze, this is what happens. You get the brushwork, and you get the halo. This rim here is iron slip underneath the glaze. So the iron slip helps the Chun Blue turn blue. So this is iron sulfate wash over the whole piece, plus the plus copper sulfate brushwork. Okay. So I'm thinking at some point, what about all this blushing I see in my kiln? What if I took a piece and I made a Sagger that was designed to blush onto the piece? I know, we're done. All right. So so this is a porcelain piece with a Chun blue inside a Sagger that's covered with a copper saturate glaze, like a 20% copper. That's the first firing. That's the second firing. Beautiful color, and that's the third firing. This is what the Sagger looks like, and you can see the piece. And then we have having fun with our glazes. This is copper sulfate brushed over Chun, which is also over the Tomoku. And then we look at this piece again. This is half Tomoku, half Chun, with purple haze glaze brushed over it. And then Chun blue. What is Chun blue? Chun blue is purple haze base with no colorant. It's as simple as that. You test glaze for 20, 30 years, you might get lucky. There we go. So we experiment every firing that we do. We have pieces that come out and we say, what the heck is that? What did they do there? How did they do that? And we have to run them down and find out what's happening. So here's all the formulas. Bing, oh, too late. Oh, too late. Okay. Come on. Come on. Okay. So all of this stuff. So I want you to go, if you do not have a cone 6, if you don't have a gas kiln and you want to get one, if you do get one, try all this out first before you go and mix up all those cone 10 glazes. Okay, thank you very much.